Now let's see this. The number of simple graphs with n vertices is 2 power nc2. So in this case we are assuming that the vertices are labeled. Okay, so what is labeled and unlabeled, I will discuss about it later. Now let's try to derive this 2 power nc2. So how did we get this? The number of simple graphs with n vertices is 2 power nc2. Now with n vertices, how many edges are possible? So every edge, so we are talking about only simple graphs. So what do I mean by simple graphs is there is no loop and there is no multi edges. Therefore the number of edges possible with n vertices will be nc2. Why? In order to form an edge we have to choose 2 vertices. So out of n vertices, how many ways can we choose 2 vertices is nc2, right? And whenever we choose 2 vertices we can put an edge between them. So that is why the total number of edges or the maximum number of edges possible in a simple graph with n vertices is nc2, right? So now let us say we have these many edges e1, e2, e3, so on, nc2 edges are possible. Now by leaving all those n vertices, how many graphs can we form is by including an edge we can form a graph, and by not including that edge we can form a different graph. Therefore each edge will give us 2 possibilities, right? One is include it and form a graph, don't include it and form a different graph. Therefore each edge is giving us 2 ways to form a graph. So 2 into 2 into 2 into so on into 2, right? So what does it mean? 2 power nc2 is the total number of graphs which are possible with n vertices. Are you getting this? So how did I derive it? With n vertices the maximum number of edges possible is nc2. Now assuming that all these edges are possible, in order to make a graph or form a graph, each edge can be included in it or it may not be included. Therefore each edge is going to give us 2 possibilities, right? Either leave it, have it in the graph or don't have it in the graph. Depending on that each edge is going to differentiate us into 2 types. So 2 into 2 into 2 into so on 2. That is why we got 2 power nc2. Now for example, if you take 3 vertices, you are supposed to get 2 power 3c2, which is nothing but 2 power 3, which is 8. So with 3 vertices you are supposed to get 8 graphs. Now see this, with 3 vertices, if I don't have anything, right? So okay, one more thing, with these 3 vertices, how many edges are possible? 3 vertices, 3c2, which means 3 edges are possible, right? So which means e1, e2, e3, right? Therefore in a given graph all these 3 may be absent, so that is why you got this graph. So all these 3 are absent or only one is present, right? Which means this way or this one or this one, right? That is how you got these 3, right? Or only 2 are present, which means 0 1 1 or 1 0 1 or 1 1 0, right? So that is how you got these 3, right? Or all are present, 1 1 1. So that is how you got this, right? So that is how with 3 edges I got 2 power 3, isn't it? Each one is having 2 possibilities, either it can be absent or it can be present, right? So now if you observe it, one thing is in this graph all the vertices are labeled means they are given names. So since you are having names, that is the reason you are able to distinguish between 2, 3 and 4 graphs, isn't it? If you had not had these names, so which means if you hadn't had A, B, C like this, then these 3 graphs would have represented one and the same. What does it mean? There are 3 vertices out of which 2 vertices are adjacent, isn't it? If you say that these 3 are going to represent the same graph, in case if you differentiate it by giving the labels, then these 3 are going to be different graphs. That is why these, in case of labeled, you are going to get this answer. So one more word you have to add here is the number of simple graphs with n labeled vertices is 2 power nc2. In case if they are unlabeled, then you could have combined these 3 into one graph. In case if they are not labeled, these 3 will represent one and the same because they are isomorphic, isn't it? And similarly these three are also isomorphic, they represent one and the same. In case if there is no names, then you can call them as a single graph also, right? And now this is the graph which is having all possible edges. So a simple graph with NC2 edges is nothing but a simple graph with all possible edges, and such a graph is called as a complete graph. Why complete? Because you are not leaving out any edge, every edge possible is being shown there, right? So a simple graph with n vertices which is complete will contain NC2 edges. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.